Hello and welcome back to my channel. I have a sore throat from past couple of days. I hope it will get over soon, so please excuse my voice. So today we are going to talk about limits of trigonometric functions. So here I'll be showing you two statements today, and we'll be finding the proof of those statements, and which are going to be used for further to solve problems regarding those trigonometric functions. So let's begin. So we have first statement here. Let me write the first statement, right? Statement 1. So it says that let there be two functions f of x and g of x which have the same domain, right? So what do you mean by that? So same domain means they have the same input function. So all the values of x are same for both f of x and g of x, so they have the same input variables. So the statement says that let there be two functions f of x and g of x such that for all values of f of x it may be less than or equal to g of x, right? So this function, overall the values of function may be equal or less than g of x. And then if limit exists at any point a, suppose if both the limit exists, like if x is approaching a, f of x exists as well as, and if limit of x approaches a, g of x exists, then the statement simply says that the limit of both these functions, the limit of f of x will be equal or less than limit of x approaches a, g of x at any point a, right, when x approaches a. So it's a very simple statement. It can be proved with a simple graph as well. So let's make a graph of this function. So we have something like this, right? So this is the x-axis and this is the y-axis, values of the function. So here we have 0. So let's make a graph. So we have g of x, let's say it looks like this, and then f of x, it looks something like this. They have the same input variables, that is same x, right? So this is g of x, the top line, and this is f of x. So for any point, let's say here, if I've chosen x equals a, so at this point we can see that first of all limit exists for both the functions, right? And then the statement is simply saying that the limit of f of x will be equal or less than g of x, which can be easily seen by this graph. So I hope you understand this, and it's a very simple explanation, very simple graph for that. So let's move on to the second statement here. So I'll write it down, statement number 2. So the statement 2 is also known as the sandwich statement. The sandwich theorem. Sandwich theorem. So the statement says that let there be three functions in this order. So we have a function of x is less than equal to g of x is less than equal to h of x. So the statement says that if limit x tends to a, that means x is approaching a, f of x is equal to L, that means the limit or the value of the function at x approaches a is L, is also equal to limit x approaches a h of x. So both these limits are same. The limits of f of x and h of x are same at any point a. So therefore automatically, or by this condition, we have limit x approaches a, g of x is also equal to L. So this is what the function says, right? And it is sandwich theorem here because as we can see, g of x is in between f of x and h of x. So the value of g of x lies in between, and when we have a limit same for f of x and h of x, so automatically the limit of g of x also equals L. So here, by making a graph, we can understand this one. So let's make, we have the y-axis, sorry, the x-axis, right? So let's say h of x looks something like this. It's going and like this, and then we have a g of x, right? It's touching here, and then f of x. So notice that all of these functions are touching here, right, at this point. So, and the reason I have drawn like this is because since the limit is same for f of x and h of x, that's why, that means they're meeting at this point, g of x and this is f of x, right? So they're meeting at this point. That means the limit for all these functions is same. This is what is stated by this theorem. So from this theorem, it is easily, we can see that the limit for all these functions is same, right? Equals a is equal to limit x approaches a, g of x equals limit x approaches a for f of x. Only at this point a, not for other points. Other points we can say that the limit is if we have here h of x, right? So that means the limit of g of x is less than the limit of h of x. Similarly, the limit f of x is less than g of x. But at this point a, all of these, the value of the limit is same. So thank you for watching, and please do subscribe to the channel, and thank you.